Okay, so in this video, we are going to talk about how to multiply and factor different algebraic expressions that we call special cases. Basically, these are shortcuts that you can use sometimes, okay? So let's start out by multiplying. So if I have x plus 3 times x minus 3, you're going to multiply that together. And if you do it normally, you'll take x times x, and that's x squared, and then take x times negative 3, so you'd have negative 3x, and then you'd have plus 3x, and then you'd have minus 9. And then when you combine like terms, those two things cancel out, so you have x squared minus 9 for your answer. Okay, so I'm going to do a couple more of those, and I think you'll see the shortcut here. So let's say I have x minus 8 and x plus 8. Well, when I multiply that out, I'm going to get x squared, and then I'm going to get plus 8x, and minus 8x, and minus 64. And when I combine like terms, that's going to cancel out, and I'm going to have x squared minus 64. Well, if I have a number in front of the x, what if I have 2x minus 5 and 2x plus 5? Well, in that case, I'm going to have 4x squared, and then I'm going to have plus 10x, and then minus 10x, and then minus 25. So again, my middle two terms cancel out, and I have 4x squared minus 25. So by now I'm sure you see the pattern that if you multiply two binomials together that are exactly the same except for the plus and minus, then the middle term is going to drop out because you're going to have a positive term and a negative term. So the formula for that, or I just have this on my board in my classroom to remind students, if I have a plus b times a minus b, it is always going to equal a squared minus b squared. So I just say when you have something that looks like this, you get the first thing squared minus the second thing squared. So when you have something like this, you don't need to go through the whole thing. So keep this in mind. Okay, and so if I give you 8x minus 7 and 8x plus 7, you're going to just recognize, oh, that fits that pattern. So 8x and 8x gives me 64x squared. 7 and 7 is 49, so it's minus 49, and that's your answer. Okay, so now we're going to go backwards. When you go from this side to this side, you're multiplying. But when you have something that looks like this and you go backwards, you're factoring. So this is really two shortcuts. So if I tell you to factor something like x squared minus 36, you're going to recognize that as this a squared minus b squared. We call it a difference of two squares. Difference because it's subtraction, and 2 squares because 36 is a perfect square. It's 6 times 6. And x squared comes from x being squared. So this can just factor into x minus 6 and x plus 6. If I have 4x squared minus 100, well, both of those are perfect squares. So that'll factor into 2x plus 10 and 2x minus 10. Now this isn't factored all the way because there's a common factor in both of those. So if you were told to factor completely, you would then factor a 2 out of both of them. This is a little bit extra. Okay, so then the 2 times the 2 is a 4, and it actually would be easier to factor a 4 out at the beginning because 4 goes into 100. So this is a little bit extra. The main thing today was to get you to see this pattern, but if you were told to factor completely, this would not get you full credit. Okay, so just keep that in mind. So let's look at another shortcut we have. Okay, so let's say we want to multiply x plus 7 squared. A lot of students will do this wrong. Okay, they will say, well, x squared is x squared, and 7 squared is 49, and they think that's the answer. And that is wrong. Do not do that, okay? Gives your teacher the heebie-jeebies, okay? So you got to remember that anything squared means it's self times itself, Okay, x plus 7 squared means x plus 7 times x plus 7. So if we distribute this out, we're going to get x squared plus 7x, and then plus another 7x, and then plus 49. So we get x squared plus 14x plus 49. Now I'm going to do a couple more of these, and you're going to see a pattern. So let's say I have x minus 3 squared. So that's x minus 3 times x minus 3. And so that is x squared minus 3x plus 9 gives me x squared minus 6x plus 9. So when you multiply that and when you multiply that, you're always going to get the same thing. So you're always going to end up doubling it. In the situation before, they were opposite signs, so they added to 0. Now they're going to be the same sign. In this case, they're both negative. In this case, both positive. And so they're going to double. So I have a lot of students that will look at this and they'll go, oh, square, double, square. Yeah, square it, double it, square it. Okay? So if I give you x minus 6 squared, we're going to square the x. We're going to double 6 times x, so minus 12x. And then we're going to square the negative 6, giving me a positive 36. Square, double, square. X plus 10 squared. Well, that would be x squared, and then plus 20x, and then plus 100. Okay, now, try this one. If I give you 2x plus 3. Okay, a lot of students will get this wrong, all right? So 2x times 2x, and if you want to pause the video right now and try to work it and see if you can do it correctly, that'd be great. If not, you can just watch. So 2x squared is 4x squared. You know, 2x times 2x is 4x squared. Then a lot of people want to just double this 3, but you're doubling the 3 times the 2x. So 3 times 2x is 6x, and then when we double that, we get 12x. And then 3 times 3 is 9. So square, double, square, but you're not just doubling this number, you're doubling this times this. And it works on this stuff too. That's where the x comes from. 10 times x is 10x, and then when you double it, you get 20x. But a lot of students just focus on the 10 and doubling it and get 20, and then they just know that an x has to go there. But when there's a number, that causes them to forget to include that number. So let's practice another one. Let's say I have 5x minus 1 squared. So my first term is 25x squared. This gives me a negative 5x when I double it, or when I multiply it. So then a negative 10x when I double it, and then plus 1, because negative 1 times negative 1 is a positive 1. So that means when we factor, if you have something like x squared plus 16x plus 64, you can do this like we've done it, or you may have learned it somewhere else, or if you've been in my classroom, then you think, well, I need my x to go in the front. I need 2 numbers to multiply to 64 and add to 16, and so that's going to be 8 and 8. But if you're looking for this pattern, you would realize, oh, the square root of 64 is 8, and 8 plus 8 is 16, so it's going to be x plus 8 squared. So this isn't quite as big of a shortcut. It's a little bit harder to notice, and honestly, it doesn't save you a whole lot of time. But if you have something like this, like let's say you have 36x squared, and then you have plus 60x plus 25. Well, now you've got large numbers, and you're either going to write all the factors of 36 and all the factors of 25, or you're going to take 36 times 25 and go through a lot of stuff. But if you recognize that 36 and 25 are perfect squares, you could say, you know what, I wonder if it's 6x plus 5 squared, because the two things are squared. And then double check it. 6 times 5 is 30, and 30 times 2 is 60, so this is true. Okay, so this factors into this. So for something like this, it's a really big shortcut. It's a very big time saver. Okay, so the rule for this, just like I gave you a rule earlier, you know, for this shortcut, the shortcut for this is when you have a plus b squared, it is equal to a squared plus 2ab plus b squared, where a is just the front term, and a lot of times it's just a letter, and b is the last term. So sometimes this a is 4x. Like in this case, the a was 6x. So this just means the first thing squared, take the two things times each other and double it, and then the last thing squared. Now technically if b is a -5, this formula works when b is negative, but a lot of students I know don't see it that way, so I write out another formula with subtraction. So this would be a squared minus 2ab plus b squared. Notice that when you have this thing squared, whether it's a plus b or a minus b, your last term is positive. You're always going to add that last term. But if this is plus, this is going to be plus. If this is minus, this is going to be minus. So if you want to write that in your notes or take a screenshot of it, that is your formula. And so this is also two shortcuts. You know, if you're multiplying and you're going from this to this, it's a shortcut. When you're factoring and go from this to this, it's a shortcut. So multiplying is that way, factoring is that way. So hopefully that helped.